terminating, non-terminating, and recurring decimals. So there's three different types of decimals we have to look at. Now decimals are when we've got a part of a number, and they're very closely related to fractions. And in fact, fractions can turn into decimals by doing the top divided by the bottom. So on your calculator, 1 over 3, you can either do 1 divided by 3 equals, and we get this decimal that goes on for a very long time, and we write 0.33333, and I can see that that's going to keep going, so I put some little dots to say it keeps going. Or your other option, instead of 1 divided by 3, will do for this one, you could use your fraction key, 1 over 4, 1 over 4, enter. Now your calculator will keep it as a fraction because fractions are nice. And so you use this button here, the two arrows, to say, please give me a decimal answer. And that equals 0.25. Or here I've got 2 divided by 7, 2 over 7. Get your fraction, hit enter, and when you've got a fraction answer, the double button here. And again, that's a decimal that keeps on going for quite a while. So 0.28571428, and that is quite a big number. Now, you do need to be able to change a fraction to a decimal by dividing with your calculator. And there's two different types of decimals that we can get when we do that. We can either get a terminating decimal. A terminating decimal ends. Terminating, ending or stopping. It stops after a few decimal places. The division's finished. 1/4 is a terminating decimal. The other sort of decimal that you can get from a fraction when you divide it out is a recurring decimal. And recurring means repeating. And these create a pattern that just keeps repeating. And that goes on forever. So even though my calculator only shows a few decimal places, 1 divided by 3, the fact that it's going 0.333333333 tells me that keeps going forever. In a test, to show you that it kept going forever, I'd used 3 dots. This is a non-terminating decimal. Non-terminating means doesn't end, but it's also a recurring decimal. So we'd call this recurring. Now it is non-terminating because it doesn't end, but it's more important that it's recurring because it makes a pattern. Now this one looks very confusing, but actually if you kept dividing it with a bigger calculator, you'd see that it does this, and it starts a repeating pattern here. And a clue is, a fraction will always give you either a terminating or a recurring decimal. So these both come from fractions. This one's recurring. So if you have a fraction, you know it'll come out as either a terminating or a recurring decimal. That's your only two possibilities. Because the other sort of decimal is non-terminating and non-recurring. Non-terminating means it doesn't stop. Non-recurring means it keeps going forever and ever and ever in its decimal places. And these do not come from fractions. These come from things like square roots and a particular special number called pi. 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 The square root. When you see a square root, it's saying, what did I square to get that number? So if I was saying, what's the square root of 25? I'm saying, what did I square to get 25? That was 5, because 5 times 5 is 25. So sometimes square roots work out as nice whole numbers. And if I do the square root, second function, and here above the x squared for square root, 25, I get 5. So that's great. But sometimes I ask for a square root of something that doesn't have an easy answer. Nothing multiplies by itself to give 2. It's not 1, because that 1 times 1 is 1. If I do the square root of 2 on a calculator, square root of 2, enter. Again, the calculator says, oh, it's just the square root of 2. Use your please give me a decimal button. I get a very long decimal, and I'll write that down. 1.414213562, and that just keeps on going. It's not making any pattern there. You can't say, oh, it's just going to go and do this forever. Square roots, unless they give you a nice easy number like 5, are going to give you non-terminating, non-recurring decimals that just keep going forever, but you never get to a point where you can say, it's just going to keep doing the same thing now forever. It will always keep doing different digits. Now there's only 9 digits. You've only got 1, 2, 3, 4, 5, etc. 10, 0, sorry. So it can only have those 10 digits in it, but they're not going to form a pattern that you can predict. If you evaluate pi, and some of you might know because it's Pi Day coming up, enter. It says, oh, I'm just pi. Please give me a decimal. Here we go. 3.141592653, and it just keeps going forever. And with Pi Day, we have a competition to memorize as many digits of this as you can and recite them. So you might like to start learning pi. And Pi Day is on the 14th of March, because when you write that in the way the Americans write a date, it's 3.14, and that's the first 2 digits of pi. So that's why Pi Day is the 14th of March. So this is our non-terminating, non-recurring decimals. They do have a special name. We'll come back to that later. But you need to be able to recognize, is a decimal terminating, recurring, or non-terminating and not repeating? So in these questions, state whether each decimal is terminating or not. If it's not terminating, is it recurring? Now, if they give us this question and I don't see these little dots, then it's terminating, because I need to know that it keeps going forever to decide if it's not terminating. So these two are terminating because they stopped and the person didn't write little dots to say, hey, it actually keeps going. This one's easy. This isn't terminating because it keeps going forever, but you can see it just goes 6, 6, 6, 6, 6. It's just doing 6s forever. This is recurring because it forms a repeating pattern. And if you were paying attention, 3.14159.265 is pi. It's not coming into a repeating pattern, so this is just not terminating. It doesn't recur, it doesn't terminate. So that's your introduction to the 3 types of decimals. Later we'll learn a way of writing recurring decimals, but I think that's enough of a video for now.